Hello chemist, Mr. Thomason here. One of the trickier things we talked about in class was deciding which ion each of the main group elements is likely to become. And there's a few easier things we can do to help us decide on those. So the first suggestion I would have is that you have your periodic table out. And if you want to write either on a separate sheet of paper or down at the bottom of your periodic table, a few notes. So first, our main group elements are the group with hydrogen is group 1, beryllium is group 2. We skip the ones in the middle. We call those the transition metals. Group 3, 4, 5, 6, 7, 8. And later on we're going to learn why these are 1 through 8. It has to do with some fancy electron placements in our next unit. But for now it's really convenient just to say that the valence electrons, or our outer electrons, are shown with these eight columns or 8 families. So it's good to look at period 2 or row 2, and if we look at lithium being in group 1, we can just write 1 dot, this electron dot formula. If we write 1 dot on one side of lithium, that shows that it has 1 valence electrons. So we call these electron dot diagrams. For beryllium being in group 2, we can put 2 dots, and it really doesn't matter where you put them, but you should show them separate from each other at first. So 2 dots means 2 valence electrons for beryllium. Boron, being over in group 3, gets 3 dots. And you guessed it, carbon gets 4 dots, and so on. Once we get to nitrogen with its 5 valence electrons, you'll find that you have to pair up 2 of the electrons. And this actually gives us a little bit of a clue as to why nitrogen does what it does in nature. So it actually forms 3 bonds because of those 3 electrons that are by themselves. So moving on, oxygen is in group 6. So oxygen gets 6 valence electrons, 6 dots. 2 of them are paired and 2 unpaired. Fluorine is up here in group 7. So fluorine gets 7 dots. And again, the ones you pair doesn't really matter. So just for this one to be different, I will be leaving the one on the right unpaired. So there are 7 valence electrons, and neon, being a noble gas, has all of its electrons paired, and neon has a full valence shell. So from here we're going to decide, well, which of these elements is likely to lose electrons. And the metallic elements like lithium and beryllium and in boron, we'll treat it as a metal right now, even though it's a semi-metal. So the ones with 1, 2, or 3 electrons are likely to lose electrons to become a positive ion. And in 5, 6, and 7, they are likely to gain electrons in order to become like a noble gas, or to become to have 8 in their outer shell. So think of them as sort of lazy elements. They want to go the shortest distance to get down to 0 or up to 8. Carbon being right in the middle, we'll say it'll either lose 4 or gain 4. So for that reason, lithium being in group 1, and all the ones in group 1, we say are going to lose 1 electron. So if lithium loses this electron, it will be lithium without that dot, 1 less electron. Lithium will have 3 protons and 2 electrons, so lithium will have a 1 plus charge, or a +1 charge. And that goes for all the ones in group 1. For beryllium with 2 electrons, if it loses both of them, beryllium will become a +2, or if you want to say 2 positive ion. It doesn't matter if you put the plus before or after the 2. And with that similar logic, everything in group 2 will become a +2 ion. In group 3, we would expect a +3 ion. And then if we look on the other side, fluorine with its 7 valence electrons you could have an electron come in here to make 8. So fluorine, it will gain an electron. So with 9 protons and 10 electrons, it will take a 1 minus or a minus 1 charge. So adding 1 negative would make it a negative 1 charge. If you want to show fluorine with those 8 electrons instead of 7, has 8 electrons on the outside, 8 of those outer electrons. And oxygen, if it took 2 extra electrons, would have a minus 2 charge, and nitrogen would have a minus 3 charge. And that goes for pretty much everything in those rows. So fluorine takes a minus 1, and everything in the halogens, minus 2 for the oxygen row, and minus 3 for the nitrogen column. So that leaves the carbon ones, everything in group 4, main group 4, we say can take a plus 4 or minus 4. Kind of depends which elements in that group and what they're bonded with. So we said boron group takes a plus 3, and here we'll say plus or minus 4. A few further examples. What about these ones in the middle, the transition metals? So these ones in general, if you had to guess, they take a plus 2 charge. So most of those have 2 valence electrons. So for iron, being right here, element number 26, it's definitely a transition metal. So we'll say it gets 1, 2 valence electrons, and iron most likely takes a 2 plus charge. Arsenic is over here, element number 33. So it's in the same group with nitrogen. So arsenic has 5 valence electrons. You can draw those in. 1, 2, 3, 4, 5. And it would be likely to gain 3 and become a 3 minus charge, because if it gains 3 to get up to 8, that magic number of 8, it will have 3 extra electrons and be a negative 3 charge. Lastly is helium. Helium is a little bit of a special one. Even though it only has 2 valence electrons, has 2 electrons total, because it's a noble gas and those electrons don't tend to react with others, we actually pair them up. So for helium, we put them as a pair, because we say, well, helium is more stable than these other, say, group 2 elements. So helium, we pair up those electrons. I hope that helps.